Well, I think when we look at our initial analysis of this type of problem, we can see that we're really working backwards, utilizing the same information as we had before, but having to work this problem using a different series of steps. Here we know organic matter content in percent. We want to know how many grams of carbon would be represented in this soil sample. So my first step would be to take the 200 grams of soil, which is the sample size in this particular problem, multiply it times the percent of organic matter that's in that soil. Now when we're working with percentages, in this case 4.25%, we should convert that percentage to a decimal. So 4.25% is 0.0425. 200 grams of soil times 0.0425 will give us the grams of organic material that are in this particular soil sample. That should have came out to approximately 8.5 grams of organic material in this soil sample. Well, remember that grams of organic material and grams of carbon are not the same. But we can go back and use our constant again. Carbon represents 58% of the dry weight of organic material. So we can take our grams of organic material, 8.5 grams, multiply this by the percent of carbon in there, which is 58%, that's a decimal 0.58, and convert that 8.5 grams of organic material into grams of carbon. And in this particular problem, that we should have came up with an answer of approximately 4.93 grams of carbon. So to validate a test, soil organic matter determination in the lab, they very often would do this. Take a soil reference sample of known organic matter percentage, run it through the test, analyze to find grams of carbon, determine whether or not they validated their test procedures in that particular case. So with those two examples of practice problems, you should not have any difficulty working a problem that would be presented to you on the review questions or perhaps later on an examination that includes this unit in the class.